In Lesson 4.6, the topic is isosceles triangles. We'll learn how to use the properties of isosceles triangles and the properties of equilateral triangles, which are just special isosceles triangles. In Lesson 4.1, you learned that isosceles triangles have two congruent sides. Like the right triangle, parts of an isosceles triangle have special names. The angle formed by the congruent sides is called the vertex angle, and the two angles formed by the base and one of the congruent sides are called the base angles. Theorem 4.9 is the isosceles triangle theorem. It says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent also. So in this triangle, if segment AB is congruent to segment CB, then angle A is congruent to angle C. Example 1 asks us to write a two-column proof. And I'm going to mark the given as we go. They said AB is equal in measure to CB is equal in measure to BD, and angle ACB is congruent to angle BCD. And they want us to prove that angle A, this is where we're going, is congruent to angle D. This time they were nice and just gave us one part of our given. So they just said that the lengths are equal. AB is equal to CB is equal to BD because it's given. If they're equal in length, they must be congruent by the definition of congruent segments. And by the definition of isosceles triangles, triangles ABC and triangle BCD must be isosceles. So because they're isosceles, we know that angle ACB is congruent to angle A, and angle BCD is congruent to angle D. Now they brought in the other piece of the bit given that angle ACB was congruent to angle BCD, because this is when we want to use it. So since angle ACB was congruent to angle A, and ACB is congruent to BCD, and angle BCD is congruent to angle D, we must, by substitution, be able to conclude that angle A is congruent to angle D. Okay, slight typo in example 2. It should be, instead of angle DCE, it was supposed to be angle CDE. Because there is no way that DCE could be 120. Would not be possible. Okay, anyway. So we know that DE is congruent to CD, and BC is congruent to AC. And they want us to find the measure of angle BAC. So first we need to find the base angles C and E. So we take 180 minus 120 is 60. So those two angles have to add up to 60, and they're equal. So divide by 2, and they'd each be 30. So that means the vertex angle of the little triangle has to be 30 also. So we take 180 minus 30, and that gives us the sum of the two angles, A and B. So divide that by 2, and they should each be 75 degrees. The converse of the isosceles triangle theorem is also true. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. Example 3 could be done a little bit better. They ask us to name two congruent angles. They mean the ones that aren't marked already. So angle L there and angle N, and we should probably use 3 letters. So they'd be called angle MLN and angle MNL. For example 3b, they want us to name the two congruent segments that aren't already marked. So it would be PL and PM. Remember, we put the bar above there to be read segment PL and segment PM. If we don't have the bar, it means the length of PL and the length of PM. Remember that a corollary is something that can easily be proved from a theorem. So corollary 4.3, a triangle is equilateral if and only if it is equiangular. So that can go both ways. If it's equiangular, we know that the sides are the same. And corollary 4.4, each angle of an equilateral triangle measures 60 degrees. So 180 divided by 3, 60. Triangle EFG is equilateral. So that means these angles all have to be the same. They'd all be 60. And segment EH bisects angle E. Bisects means cut in half. So that means that this angle would have to be half of 60. So that's angle HEG. And EJ bisects angle HEG. So that's half of that again. So first they want us to find the measure of angle HEJ. Well, we just said that would be half of the 30. So that guy would be 15. They're both 15. And then they want us to find the measure of angle EJH. Okay, if that is 15 and this was 30, that whole angle up there would have to be 30 plus 15 would be 45. And we know this angle was 60. So all that's left is 180 minus 105. And we get 75 for the measure of angle EJH. For example 4b, they gave us the same exact diagram, and they asked us to find the measure of angle EJG, would be this guy. Well, it looks to me like that is an exterior angle of that triangle EFJ. So all I have to do is add the two remote interior angles. So 60 plus 45, I get 105 for the measure of angle EJG. Okay, so our big ideas for lesson 4.6 were two sides of a triangle are congruent if and only if the angles opposite those sides are congruent, and a triangle is equilateral if and only if it is equiangular.